Welcome back, students. This is the session 29 of NEET Physics, and the topic is rotational motion. The question for this session is written on this board. The question is a round disk of moment of inertia I2 about an axis perpendicular to its plane passing through its center is placed over another disk of moment of inertia I1, which is rotating with an angular velocity omega about the same axis. So we have to find the final angular velocity of this combination of disks. So here in this question, we have to use the law of conservation of angular momentum. Law of conservation of angular momentum. So the law of conservation of angular momentum says that in the absence of any external torque, that is, in the absence of any external torque, the angular momentum of the system is constant. That is, see, the torque is equal to rate of change of angular momentum. So if torque is equal to 0, so it implies that the rate of change of angular momentum is equal to 0. Or in other words, we can say that angular momentum is constant. Angular momentum is constant. So here we will be utilizing this concept in order to solve this question. Now in this question, there is this is a disk of moment of inertia I2 about an axis perpendicular to its plane passing through its center. Is placed over another disk of moment of inertia I1, which is rotating with an angular velocity omega. So the moment of the angular momentum of the disk rotating with the angular velocity omega is equal to, see, the angular momentum is given by I into omega. So here the this moment of inertia of this disk about an axis which is perpendicular to its plane is I1 and its angular velocity is omega. So the angular momentum of this disk, which is rotating with an angular velocity omega about the same axis, means about the axis perpendicular to its plane. So and the axis of this rotation, the axis of rotation of this disk and this disk, which is placed over this disk, is the same. That is, let us say this is a disk. So this is the axis of rotation, you can say, and this axis of rotation is perpendicular to the plane of the disk passing through the center. So this is the center. So the moment of inertia of this disk having the moment of inertia of this disk which is rotating with an angular velocity omega is I1 about the same axis. So now when this disk, that is this one, this disk which is having a moment of inertia I2, it is placed over this disk which is rotating with an angular velocity omega, then angular momentum of the combination, that is the combination of disk. Angular momentum of the combination of disk it will be equal to the sum of the moment of inertia of these two disks, that is I1 plus I2, into, let us say, omega dash. Omega dash is the you can say the final angular velocity of this disk combination. That is, and this is the angular momentum of the combination of disks, that is when this disk of moment of inertia I2 is placed over the disk having this moment of inertia, having the moment of inertia of I1. Okay. Now, so the now this is the angular momentum of the combination of disks. Now, when the external torque is 0, then in that case, as I have just explained, that is torque is given by dl upon dt, and if torque is equal to 0, then dl upon dt is equal to 0, or angular momentum is constant. So when angular momentum is constant, we can say that the final angular momentum, that is I1 plus I2 into omega dash, it will be equal to the angular momentum of the disk rotating with this angular velocity omega will be which was equal to I1 into omega. So this will be equal to I1 into omega. So this is the angular momentum of the disk having the moment of inertia I1 and which was also rotating about the same axis, that is the axis perpendicular to its plane, or we can say it is the same, that is the axis of rotation of both these two disks is the same, and the axis is perpendicular to the plane of the disk. So in this, so we can say that this omega dash will be equal to I1 omega divided by I1 plus I2. So here the correct option will be equal to, that is I1 omega divided by I1 plus I2. So the correct option here is C, and the final angular velocity of the combination of this disk will be equal to I1 into omega divided by I1 plus I2. So here the most important thing is that we have to use the law of conservation of angular momentum, that is in the absence of any external torque, the angular momentum is constant. So using this concept, we were able to solve this problem. So thank you very much for joining this session, and in the next session I will be continuing with the same topic, that is rotational motion. So till then, have a nice day. Bye.